How's it going, everyone? Eul here again. But it is time looking at the Enterprise UI Development, which is a course taught by Steve Kinney, head front-end engineer at Temporal. And the theme of looking at this specific course is to, if you are an UI specialist, over the couple other videos that I have in my YouTube channel, where first we started to describe is how can we create now this user interface, initially with HTML, CSS, and JavaScript, and then why React exists, what is the problem that React solves as a way to describe UI, and what are now the challenges that React offer, which is adding interactivity, and then how you can manage your states, as well as dealing with side effects. And then how that leads us is to look at how you can now, for example, the challenge of handling is or managing his state with patterns like Flux or architecture like Flux, allows us to have a predictable way of how we can now update or state in our application. Specifically, how can now is keep track of needed change on that data. When we need to keep, when we need to keep track is needed change to that data that needs to occur, and we need to do that in an intentional way. That's the whole premise here. We need to actually find a ways to keep track of how all of this necessary change are applied to the data, and have a predictive way for doing that with intention, so to prevent any race condition and that kind of thing. So that's why we have, for example, now Redux, right? So Redux help us to do that, and also Redux introduced some challenge, and how now Redux RTKey actually come up to solve those challenges. And when you now know how to build this user interface, so your buttons and the sidebar, and then you're going to build all of this specific elements to actually build the web page or the web app. Now a lot of the time we need to know is what are the particularly fundamental, especially in today's world, as a way to first know the front-end design system, how we're going to build, how we're going to design those front-end applications, from a course taught by Yves Ray, okay? And once we know how to build that, we need to also know how to maintain that for enterprise, for companies. That's what we have here is in today's. So this is what we're gonna do in today's video, and how now for lead UI developers, which is eventually I think I will be one of them. And thanks to Steve Kinney to actually is now describe what are the problems that we need to face, especially when we are going to not only build UI applications, design UI systems, front-end systems, but also how you can maintain that, which is, after all, if you, for example, are working for financial application or healthcare or e-commerce, you want to make that work as much as possible over a long period of time, while still providing you new rich features, and solve some of your problems, especially in those areas that I mentioned, right? In the case of finance, you can easily check your bank account, and also is your transaction history. Who are you going to send data, and so, for example, deposit and withdraw. In the case of the healthcare, is that okay? I want to now monitoring is my own daily activities, and in the e-commerce, I want to keep track of all of this order, and where at which stage my order is currently at, right? Let's say I order some of creatine or whey protein or some food cats. You shouldn't. Yeah, I prefer to order is yeah, I'm quite biased to that. I prefer to order is whey protein or creatine than buying food for my pets. But if I have pet, of course I will do that. The reason of that is quite personal. My POV. If you are good with yourself, if you take care of your health, then you can take care of others in terms of so physically, mentally, and spiritually. But in any case, so so that's the reason why we are looking at this enterprise UI development. So Steve Keeney say that because doing that is something that is to require you a lot of thinkings and a lot of first things first, you need to identify what is the problem that you want to solve, and in this case is maintainability. So how you can make your code base maintainable over a long period of time with a wide range of contributors in large teams. So for that, there are some concepts that we need to understand. Pretty much to the concept of immutability, which is, I know that go beyond the scope of this course, or concept like 420. You didn't know that, and that now is widely popular. But the thing here is that it's important to understand is not only the problem we already described, as well as some of the concepts and some definitions about these problems, so we can now have a better idea of what's going on. How can we provide some sort of solution, and then act accordingly, follow these particular patterns and practice and that kind of thing. But first things first, we need to understand the problem. So I already mentioned that was the problem, and which the problem is maintainability. In the English definition or in the law definition, in thermodynamics, is, well, to prevent is entropy, decay, which is you are fighting. That's quite interesting. You are fighting, or you're not fighting. You are trying to find a solution against natural law. Oh, here we go. But in any case, I don't want to get too philosophical here, because the idea here is just to mention all of these particular topics, and then a more practical sense of what we're gonna do in this landscape. All right, so way to now manage this UI, enterprise UI development. So we need a little bit of philosophical questions, which is what maintainability means, and that is, maintain your oven, fridge, if you have a motorcycle, good, cell phone, even yourself or your pet. Each one of those requires different things to do in order to maintain, or in order to let the entropy don't hit you so hard. Okay, so for example, in the fridge, well, this is something quite trivial. You need this sometimes one in a month, or one in a 2 or 3 months. You're gonna clean that things internally, right? It's a way to avoid any fungus member inside of your fridge. Similar with the bike. Hey, you need to actually keep up the. You need to keep the change oil, as well as. So keep the change oil, the tires with the proper air pressure, as well as the gas. And then after a certain period of time, let's say 1,500 kilometers, yes, I'm using kilometers, 1,500 kilometers, or every 1,500 kilometers you need to do this. Uh, and you also need to, after 3,000 kilometers, you need to check the brake system, check the electrical systems, and so forth and so on, right? So that's quite interesting. So I mentioned each one of those topics, and also, for example, in yourself, if you want to feel good with yourself, which is why you can see me like that. Right? You can see me someone that actually do exercise, got to hit the gym and that kind of thing. I actually follow some things because I have a particular problem, which is I want to look good as much as human possible, as more as harmonically possible it can be, and also feel good about it. So because of that, I decide, similar to this course, what we're going to talk about is like there are some systems that I need to follow in order to keep myself, to solve that problem, to feel good. This is something interesting because we a lot of the time separate emotion with feelings, but the reason, the logic serve the emotion. Yeah, I don't want to dive into the philosophical aspect of this, but the whole point of this is to, if you want to make your applications maintainable as a way to prevent you the feeling of frustration anytime you want to add something or change or migrate and that kind of thing, that feeling, that emotion, okay, the logic serves to that. And the logic in this case is what are the systems, or what are the practice that we need to do as a way to make that happen, to make our life much more easy, as a way to worry, as a way to now focus our attention in other things that are also relevant in our life. That revelation is something important to apply to your life, because you're not only going to be able to solve your own problems, as well as experience that, but also capable to solve someone else's problems. And when the time is right, when you are the person, when the problem actually occurs, you will be the right gal, the right pal, the right gal to solve it. Okay, so here we are. Basically, here we are. So what are the systems or the things that we need to actually is to understand as a way to now make that happen? This course is focuses on the infrastructure. It's the basic installations needed for its operation. All right. In this case, the maintainability, for its economy, for its judicious use of resources. Now, with that, all right, this particular way of doing this kind of thing, or this infrastructure needed for that, it came with taking inspiration from, for example, for how now Amazon actually is architecture, that kind of thing, and to me is quite interesting. Okay, components of a well architecture UI app. Not sure. You have the integral, medium, understanding web app architecture and its components. For example, Amazon. Okay. AWS Well Architecture builds secure and that kind of thing. Builds your app user interface with page. AWS Well Architecture Framework. Reference architecture example and best practice. Okay, AWS Well Architecture and the 6 pillar framework: operational excellence, security, reliability, performance efficiency, cost optimization pillars, and sustainability pillars. But when it comes to the UI, okay, AWS Well Architecture guidance, AWS Well Architect reference, cyber agent, and NEC. AWS Well Architecture patterns, engage in the AWS Well Architecture pattern. This is quite interesting, but because it doesn't mention anything related to the UI. Yeah, it doesn't mention anything related to the UI. AWS Well Architecture tool, pillars, lens. Oh, but this is from AWS. I'm sorry. Okay. 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 Perhaps design principles might help here. Okay. AWS Well Architecture here. Interesting. So why am I stopping here? Yeah, you know, perplexity, bro. Perplexity. Yeah. Components of a Well Architecture UI app. Provide links of your search. It's like generate a table of the component of a Well Architecture UI app. Provide links of your search. Okay, it's like no, quite, but not. It's like what are the components of a Well Architecture UI app, right? Of a Well Architecture UI app. Provide link of your search. Provide links or search from top industry. Search for top industries. Search from top tech industries or top tech companies. Okay. Search from top tech companies about their definition and process. Okay, so what are the components of a Well Architecture UI app? Search from top tech company about their definition and process, and provide links provide links based on your search. It's a UI. This is Integral, mobile architecture, Star Knowledge, Enterprise Monkey, application layer, database layer, and client-side component. Middleware, security measure, performance optimizations, like this. So conclusion, a well-architectured UI app integrates these components cohesively to deliver an effective user experience while maintaining performance, security, and scalability. Performance, security, and scalability. By focusing on this area, developers can create applications that not only meet user needs but also adapt to future demands. Web application architecture, what is the source of this? Star Knowledge, Enterprise Monkey, and Integra. Understanding web architecture and its component, web application. How do tech companies integrate UI design into their web applications? But is this, we're talking about now the system design, presentation layer, application, database, client-side components, middlewares, security measures, and performance optimization. So all of these particularly in specific topics, so according to, because it's more like UI. It's for UI. So the thing here is that with all of that, all right, so the thing here is that with all of this, let me actually okay. This is Advanced Redux. Now, and then we got it. Okay. Of course.
Think a lot about when I started at my 1-point ticket or these things, because define what it means to build a maintainable application out, right? Across the road. Cool. And so again, this theme of like automation. If I had to, and I did have to because I prepared for this, think about like what are all the components of like a well-architected, and that's a word that I don't love, but I stole from Amazon, in terms of their like cloud services. What are the pieces of a decent like front-end architecture that you need to have kind of in place to be able to consistently ship software?
Okay. That's a very different question. That's a very different question. So what are the pieces that we need?
Of a decent like front end architecture.
Exactly. So what are the pieces of a decent front end architecture? Okay. That allow us to ship code.
Architecture that you need to have kind of in place to be able to consistent.
Okay. That allow us to be consistently ship software, right? Yeah, what are the pieces of decent front-end architecture that allows to be consistent ship software? Okay, so you got now is this, right? So you got now is modular design, component-based architecture, micro front-ends, continuous integration, continuous deployment, which is something that we're gonna do. Performance optimizations like caching strategies or performance measurement tools, testing and quality assurance, design system, create a design system that includes reusable components and style guide, and security measures, as well as documentations and standards. But again, all of this is just as a way to now, from the Steve Keeney perspective and experience, is to say what are the things that so what are the infrastructure, what are the basic operations, what is the basic installations needed that allow us to guarantee our operations, in this case, deliver ship software consistently. Okay, so what are that particular systems that we need to have in place, with the infrastructure that we need to have in place? So, well, similar with, as I mentioned before, with other way of how you can organize and manage your own systems, or similar as some sort of system that you need to, for example, provide maintainability to a bike, to yourself, to your oral health, even to your body, as well if you have kids or pets, So all of these things that you need to have in place to actually guarantee that particular operation. And in our case, to guarantee us the ability to ship code consistently, right? That's one, because that's actually what is make this code maintainable, right? Is the ability and the confidence that we can have when we now add a new feature or change something or migrate or update dependency without the fear of breaking something, or to reduce that as much as possible. And if something wrong happened, we can quickly take a look at what happens without breaking our application, or revert and fall back to a previous state. I think that immutability here has a lot of things in common. So if you, for example, are shipping code that is breaking, if you ship code that breaks, and at some point, you want is to reverse those changes at a previous state, as a way to contain that propagation. And here is when some challenge came here and say, hey, you know what? But what happened with those that are already suffering the consequence of those change? What you gonna do? You are going to go after them. You're gonna find, so they becomes defective. They actually carrying this defective. So you can release this a new patch for them. So hey, let's go to release a new patch that actually solves a particular problem, and so on and so on and so forth. Yeah, welcome to software. welcome to welcome to build something that is never finished. It's like your building is the project of your life. Even though that you die, you are never gonna be finished or complete. Even if your time is running out, even if you're pass away. But in any case, but this is the components so far of the well architecture, or aka the infrastructure needed to guarantee us to have to the infrastructure needed for us to ship code constantly. So we have now the testing system, as well as the build system, as well as the static analysis. And one of these components of this whole architecture is important to have now, or at least have a mental model of, or pyramid of needs, or this Maslow pyramid, right? Right? Or pyramid of needs. It's interesting that we all boils down this to a pyramid. Is that all boils down to a pyramid? It's a psychology theory. A theory over human motivation. Again, this is a theory, and we use a pyramid as a way to focus our attention on something, as a way to use the mathematics for that, the geometry. A theory of human motivation is 1943, after the Second World War. Exactly. So not only in psychology, not only in the field of psychology, but also in business marketing and advertising. Maslow formulates his theory on a hierarchy of needs. Let me actually read this in English. That's right. But I think this is when the psychological aspect of the person that are building software to solve a particular problems kicks in, right? That's quite interesting. The hierarchy of needs is split between deficiency needs and growth needs, with two key themes involved with the theory being individualism and the prioritization of needs. While the theory is usually shown as a pyramid in illustration, Maslow himself never created a pyramid to represent the hierarchy of The hierarchy of needs is a psychological idea and an assessment tool, particularly in education, healthcare, and social work. The hierarchy remains popular framework including sociology research, management training, and higher education. But the ingredients here, so transcendence, self-actualization, which is what I'm doing right now, is I'm self-actualization of the thing that I'm doing here, aesthetics, cognitive, esteem, belonging and love, safety, and physiological. Safety and physiological. Personal development, psychological needs, physiological needs, safety needs, love and belonging, esteem, and self-actualization. As the personal development happens, you realize that needs intensity. Exactly. You realize that those actually, the physiological needs actually will decrease over time. I don't know who made this chart. Philip Guten own work, Dynamic Hierarchy of Needs of Abraham Maslow. Here, individual in society. Simplified hierarchy of needs, physiological needs, safety needs, belonging and love needs, STEAM needs, and self-actualization, achieving one's full potential, including creative activities. Basic needs, psychological needs, okay, as well as self-fulfillment needs. So, again, the idea of this, and I know that I'm taking a huge tangent here, is to be able to describe now in terms of the maintaining of this large code bases with a wide range of contributors in large teams, so our code base can now long live as much as possible. So the priority here are quite different. When you need to maintain, or when you want to solve the maintenance problems, for example, is your health, physical, mentally, and spiritual health, or for your pets, or you want to maintain is the fridge, or the motorcycle, or a bike. You get the idea. So yeah, I'm quite redundant here, and I want to comprise that by saying all of this is just as a way to recognize is what are the problems, what are the feelings that we're passing through, especially when we are doing this kind of things, building front-end applications, and then trying to maintain that there is a feeling there that you are actually dedicating time to something that will gonna help society over the long run, but that as you do that, or as you build your particular software applications, you're passing to, and that is a lot of the time frustration. So we need to find a way of how, based on this emotion, based on this frustration, how can we come up with some reason, with some logic, to help us prevent that feeling. And in the context of software, how can we now ship code software constantly? So this is what we have here. So this is the problem. And then using now some of the external resources and tools and frameworks for other places, for example, of the Maslow pyramid, which is the pyramid of needs. When you say, hey, in our case, first it's important to understand what is the problem that we're trying to solve. I think that's the number one rule. So we can now define some of these basics of needs, or some of the things that we need to do as a way to now make this code maintainable. We can easily add, extend, change, easily add, extend, migrate, or update dependency as easy as possible, right? So this Maslow pyramid of needs for enterprise UI development as a way to make these applications maintainable over a long period of time is like this base, okay? We need to define is the systems. So for that we have now the testing, as well as the building system, the testing, the build system, and the static analysis. So on top of that, then we now is to define what are the process that we need to do. So code review is one of them. So this is the know-how, or the how process, the how to do this. Well, with code review, documenting frameworks and having blueprints when we need to actually is add some code, mutate, or change some codes, and also is the and also is the yeah, this is all the blueprint. This is all the process that we're going to briefly describe it, right? So, well, we're gonna have to do this code review, as well as documentation, document the code base as well, and having some blueprints that allows to solve some sort of patterns that happen here. For example, here, some sort of patterns, some sort of recurring things that happen over and over and over, and we know what to do for that, which is the architecture, which is the abstraction that we need to use, which is the state management. All of this is on the UI development. All right. So for that, okay. As I mentioned before, the thing here that we're going to now is have a more practical approach of how can we do this kind of thing. Sorry. Of how can we do this kind of thing, okay? A more practical approach of what are the things that we're gonna find in our code, in the way that we need to do that, the reality over philosophy, okay? And some of the tools that we're going to use in this course, right? Which is React, TypeScript, Vite, which is something that I really love about that. Vite, testing library, as well as Playwright. So, on that topic, first we're going to now talk about is the unit testing. I don't know why exactly. First we're going to talk is the base of the system. We'll talk about the system, like the testing frame, the testing system, then the build systems, and then the static analysis briefly, and then how you can combine that as a way to now have, as a way to know what would you have to do in the work. So first thing first is the testing. So here we're going to talk about briefly about what testing is. This is a spectrum of testing. You have unit testing and end-to-end testing. So unit testing is just a way to test that a particular function act the way it is supposed to. It is great. It is pretty much like testing one single thing, right? Like this. And then you have now is the A2E, the end-to-end testing is like how now the user is going to be use this entire bottle, right? So what is the process that the user is going to be, what the process that the user is going to follow here through your applications, right? A good example is like starting from if you have an e-commerce, what is this particular process of buying something, or if you have now a financial application, what is the particular topic. So how you going to define is the withdraw or deposit money in there. What happened here, this kind of tests are very expensive because you don't own a lot of the infrastructure in there. So we're gonna see that integration testing is something in the middle here, where we can now test multiple units, as well as the component testing, which is something that it was introduced by Airbnb with something called Enzyme, and now this has become as a way to actually test your component UI in the way that it's supposed to. So we also look at some sort of jargon and terminology needed to understand is the unit testing, which is what is assertion, what is assertion, test, as well as test suite. All right, and now a more practical approach of how we are going to actually write this kind of application. or these unit tests. So first, we look at how to set up our testing environment, then write some basic tests as a way to get yourself familiar with what are the things that we need to check here, and some advanced techniques that we're going to also see, especially useful for async operations or async data that you need to do. So not only timers but also promise, for example. And then after you define all of your tests, we're gonna go into our first foray to build and set up or to set up a build process with the aforementioned tests to make everything work as expected. So good. So yeah, well, we first look at how you can write your tests. In this case, Vite, which Vite is a very convenient a library, or in this case, front-end tool that allows us to not only is running the dev server while providing its hot model reloads and redoes the feedback loops, but also is to provide now an easy way to migrate your tests by running the browser related features in testing, as well as provide you a test environment to do that, and make it making Jest migrations easily to Vitess. So you can also put this Vitess as the global, which is something that if you are now migrating all of your tests from Jest to that, you a lot of the time will like to actually do that, right? So we also look at what are the most common or the syntax, the keyword that we're going to use in our test, like it and test. There's no difference in there. You can also have now is the test it fails as a way to check some sort of conditions, and also is to return is a promise for this. Works when returning a promise, and how you can actually do this. Expect this should fail not to be totally the same. And some of these framework actually use DOM or not. And how you can also use in your test, use the run if and skip if you're working on a server-side environment. Great, cool. So as I mentioned before, Vitess provide all of the things. So it provides a faster hot model reload because it is built on ESBuild, which is written in Go instead of JavaScript model bundlers on test environments or test runner like Grunt. So now we can actually harness the power of Go to actually run the dev server, and also it provides a better ESM support. It's compatible with this ECMAScript model definition, as well as simplify the migration, something that I've already mentioned, handling the browser-like environments when you're running, for example, your component testing. Something that we're going to see that. Improve the error reporting, because now you can run a particular command that is going to tell you, hey, here is on this arbitrary port, you're going to see all of these errors nicely, as well as a flexible configuration for that. So when you are now testing function, when you're testing is function, we are now talking about is on the JavaScript language. What you want is to now test JavaScript and all the applications that you define inside, and all of the objects that you define here. So because of that, it's important to understand now the fundamental of this, the value reference or pass by value, okay, referential equality and value equality. Why this is important? Because after all, if you are assigning property to a identifier or a variable, you need to know what's going on behind the scenes. So if you're using primitive, this is actually creating a new space in memory. However, if you use objects, you are not only telling to the browser, to the language, to JavaScript, hey, create this particular structure, and putting in this box here, in this drawer, putting it here, which is the address in memory. So now it'll makes a lot of sense when you need to work with that or mutate with that. It's like, let's say you have a drawer and then you define that this space will only be for socks. Okay? So as long as you put socks in there, you can change the socks order. You can now put different socks color in there. But as long as it's a sock, you know that you can have access to that record. So in terms of JavaScript here, we need to talk about is the value equality and reference equality. So reference here stands for, hey, is these two objects when I'm telling to JavaScript to create them, they are the same in memory? No? Alright, that's referential equality. And the other is value equality. I don't care where you put, in which position of the drawer you put those objects, those my socks, but I just want to check if they are the same in terms of value. Hey, is this socks that you put in this drawer are white, red socks, like the team, sport team, right? But the idea is that. Okay. So once we're able to understand is the referential equality and shallow referential equality and value equality when we need to create objects or clone objects. There is something known as the shallow reference or shallow equality, as well as the deep equality. So shallow equality, what it does is to check if the objects, the key and the value actually have the list of properties and values are the same. Okay, this is shallow equality, and it does that per level. So if you have a nested object or an object that has more other reference, all right, then deep equality, what it does is to check that the property and the value of this, the property list and values at each levels are the same. How you can achieve this deep equality, you may wonder. There is some alternative, for example, like JSON, JSON stringify. It doesn't work with functions, and then you can also have some other alternative, for example, to create that deep equality here. Say deep or shallow copy and deep copy, right? For example, here deep copy, all right. So one way to make a deep copy of JavaScript object is if it can be serialized. To use it as a stringify. So we need to take this huge object with all of these different levels, all right, and serialize into a string, and then convert that JSON object into a JavaScript object. So this is the way of how you can now create this deep copy. Or in other words, you say, hey, I'm going to create now a new reference in memory. So I'm telling the JavaScript, hey, please create now the same object here in another memory address. Why this is important, right? This comes now for the terminology of the immutable data, that kind of thing. There are also some APIs that provide you to do this. The Web API structure clone also creates this copy and has advantage of allowing transferable objects in the source to be transferred to a new copy rather than just clone it. It also handles more data types such as error. But note that structure clone isn't a feature of the JavaScript language itself, it's a feature of the platform. Instead, it's a feature of browser and other JavaScript hosts that implement Web API. And calling structure clone to clone a non-serializable object will fail in the same way that the calling string, JSON stringify. To serialize it will fail. So it talks about is serializable, okay. But is that because of deep copy share no reference with its source object, any change made to the deep copy do not affect the source object. However, while the object in the code above is simply enough to be serializable, many JavaScript objects are not serializable at all. For example, functions with closures. They can't, okay, it can do that. Symbols, objects that represent HTML elements in the HTML DOM API. Recursive data, and many other cases. Calling JSON stringify serialize the object in those cases will fail, and there is no way to make deep copy of such object. But in any case, the whole point of this, right, that we take quite tangent, go back here, and say this equality or this assignment, okay, referential equality and value equality is something that you have to be, you need to refresh that, go back to the basics as a way to, when you need to create your test, okay, and especially when you say, hey, I'm expect that these two objects to be the same reference, you use it to be. But if you only care about the values, you use the to equal for that. And this equality, for example, to equal, correct me if I'm wrong, but this equality is going to do a deep copy or a shallow copy. To equal, assert its actual value is equal to receive one and has the same structure. If it is an object, compares them recursively. You can see the difference between to equal and to be in this example. Exactly, to equal, a deep equality will not be performed for error objects. Deep equality. Only the message property of an error is considered for equality. To customize equality check, to customize equality to check property other than message, use to customize equality to check property other than message. Only the message property of an error is considered for equality. Okay. To customize equality to check property other than message, use spec add equality testers. To test if something was thrown, you throw to error. Again, but as we can see here, remember that at the end of the day, we need to start from the small things here as a way to make your code actually work as expected with the testing here. And that is, hey, is this equality reference or is this equality value? Okay, do we have now this deep equality or is this shallow equality? All right, and well, the to be object compares the object that is for equality reference, which is something interesting, and the to equal, it compares shallow and deep equalities. Well, it compares to equal, it compares deep equality. Okay, there's some caveats. There are some caveats. And this is the list of the greatest hits of testing, right? So you have to be close. To be close is especially when you want to actually test is floating points numbers. The other is to be instance. Hey, is this now proper prototype to be instance? Okay, is this object the prototypes here? Okay, is this object the prototype has a reference to that object? Okay, because remember, after all, especially objects has this inheriting nature of the prototype change, where the prototype has the prototype or the proto, that this proto has a reference to the objects. And I want to look at the anatomy of the object. I just want to refresh that. Object anatomy in JavaScript. Okay. Setting object members. Object prototype, this one. Or empty cabinet. Okay, object prototypes. Here we got exactly the prototype chain, right? In the browser console, try creating an object literal like this, right? You say, hey, done. And you see my object greeting from Madrid, but this object with one data property, city, and one other methods, greets. If you type the object name follow in this period, like my object, the console will pop up a list of all the property available on this object. Okay. There you go. There is a lot of other property like this. This is the find getter. Again, this is now private properties. You know, this is private property. So you have the constructor, you have the greet, you have the has own property, you have its prototype of. Property is enumerable to locate string to string and value of. Okay, has own property, has that. is prototype off. So try to accessing one of them to stream. It works even it's not obvious what to stream does. What are these extra property and where do they come from? Exactly. Every object in JavaScript has a built-in property which is called prototype. The prototype is in itself an object. So the prototype will have its own prototype, making what's called prototype change. The change ends when we reach a prototype that has null for its own prototype. The property of an object that points to its prototype is not called prototype. Exactly. The property of an object that points to its prototype is not called prototype. Its name is not in standard, but in practice all browsers use proto. The standard way to access an object prototype is to object.get prototype off. When you try to access a prototype of a property of an object, if the property can be found in the object itself, the prototype is searched for the property. The prototype is searched for the property. If the property still can be found, then the prototype chain is searched, and so on until either the property is found at the end of the chain is reached, in which case undefined is returned. So when we call the object.toString, the browser looks for string in my object. Exactly. It say, hey, look for to my string in my object. Can't find it there, so look in the prototype objects for that. But it's because it has now that object has a link, a ref. So this object not only have internal methods, but also have other internal methods or internal property, which is the proto, which now has a reference to the object prototype, to the object. So the object prototype here, every object in JavaScript has a built-in properties, which is called prototype. So the prototype here is the built-in properties that every JavaScript object contains. The prototype is itself an object. So the prototype will have its own prototype, making what's called the prototype change. So all of this, again, I'm just recapping here as a way to have now is this understanding, setting a prototype using .create, using a constructor, and all prototypes by inheritance. So object-oriented class programming. So using now classes for that and the kind of thing. So the whole point of this is that the idea, all right, so the idea here omitting constructors, inheritance, encapsulation, private method, that's your skills. Working with JSON. He earned a degree in radio and television. What the hell is this? Maniac Mansion. Oh my god. Okay. ECMAScript standard. Extremely poor quality, man. Yeah, I mean. Okay, that's quite interesting. That's quite wild, bro. His journey here. Yeah, when I'm reading this specification, to me it's like, what the F is all of this, bro? It is quite arcane, man. It's very arcane. But this is the way it is. But this is the way it is. But in any case, abstract operations. But this is on the specification, and the other is like what is really is all about. You know, so the idea of this, right, is that once we are now be able to check up the to be instance of, all right, is to say, hey, the reason of doing this is to understand not the mechanism of how these things work, is to say, all right, now the to be instance of, what it's gonna do is to look at that object that you give me to. And I'm gonna take a look at their prototype if they have an instance of, right? To be instance of. I'm gonna check the prototype if this has a link to that object, to the function construction, or to the prototype. Where now the prototype here is now an object. So the prototype here, okay. So the prototype here is an object, okay, that has built-in properties, and that is pointing to that object that was created, and so on and so forth. So hey, if this has, so what does it mean when we say this? Right. Is to measure if utilizing to check whether a given value is an instance of a specified class, the receive class. This is particularly useful when you want to ensure that an object is created from a particular constructor or class. Constructor function. Exactly. Hey, is this was created by a constructor function or a class, which is using behind the scene is that, and how it's going to check that by taking a look at the proto that has a reference to that has a reference up to the prototype change, to check up if that value that you're passing now is an instance of. All of these subtle things are very important to understand, especially if you're gonna test your applications. All right. But again, here we're describing is what are the most common of that, and also be able to describe quickly what is doing each one of them. The other is to be undefined. To contain, where now contain, what it does is to check if the contain is check if an string belongs to an array of a string. To throw error, useful for functions to match to see if a particular string actually is in a string, and to match object is to check if a subset of objects of a subset of property now are on these objects, right? And expect any is to see, I don't care the value that this property has, I just care that is of this particular type. So this is what we are actually doing here. We have done so far here, and that is quite interesting, quite also compelling as well. Very, very compelling. So let's get into this, right? Some of the key aspect of when you're writing your test is like define the setup, test execution, as well as the assertion, right? And again, this is something that you're going to do, especially if you're going to write your tests. Write your tests that are where you have everything at a glance. So repeating code is actually quite useful, especially if you're going to write your tests for your future self. Don't try to be smart here. Don't try to do some. No. Keep it simple, man. Keep it simple. And then some techniques, especially when you want to deal with this asynchronicity. So you have now technique like async and await, or use the resolve or rejects, more useful when you're trying to catch errors. And for bug report, it's like you take the bug report, and then the problematic things, you write a failing test to make it pass. And the other is the timer. So anytime you need to interact with DOM elements that appear and vanish after a certain amount of time or date now, is when you're gonna use them. So here we are. That's what we're gonna do. And that is and that is where we are. What in the F? Okay, follow me along with it here. You got it. Okay, so it's actually running this test item slides. So yes, so now we're gonna test is a reducers, which is quite interesting here. So this reducer here and add in all of the actions that we're receiving here. Remember that after all, anytime you want to write your test, it's just so you write tests based on the user stories. Okay, you're gonna write your test based on your user stories. So it returns an empty array as the initial state. It supports adding an item with the correct name, and you get value tests and then results and that kind of thing. Something that I already did here. The only thing that I want to check is the iPhone actually is the value that I expected for. Useful, especially if you have an ID that is auto-generating on the client side using UUID. All right. And actually, I just want to check is some of this element or is some of them actually are there. ID, name, and package. Another interesting will be is that how you, for example, default new items to pack status of false. Let me actually remove this assertion here. Okay, the other is to do. Okay, prefix IDs with items, as you can remember, to match. That's what we want to do. Expect object containing. Expect object containing. Interesting. and I prefer to use here is this. Instead of doing all of it, which is a great thing, but I'm gonna do this now is here. But things, let's going to do this. Hey, this is the result. Okay, this is the result. This is the setup function, which is match. Match, or you can call this as prefix of item here. Say item here. Okay, now you define the setup. It's time to define the logic, the testing logic, which is in our case is to say, hey, the testing logic as well as the assertion, which is in here. I want to say, once you create this new object, right, I expect that the result here to match, which is I want this to now check if a particular property actually contains that. All right, so in my case, because we are returning is a new state from the reducer, and this is only one element. Okay, I want to check if the ID here, all right, to match the expected string, which is the prefix, right? If it is, great. So now it's run that and it say, hey, yeah, it passed that. If I put this in to do, it say, hey, one pass and 2 tests. So this is test file 1 and 2 pass as it is. So this particular test actually worked as expected. So far so good. Actually, you are generating it with the proper prefix here, items. Okay. The other is that defaults new items to a package status of false. Okay, so when you create new objects, the package status must be false. This is a great opportunity for us to say, hey, what's going to define is the setup function, what is the result, as well as the say status or default status, right, which is false. Okay, I'm going to define is now the setup, the testing logic, which is I want to expect that this result object that is returning is now an array of items. Okay, their values, okay, their values, I want is to make them that status, okay, because we are returning is now an array of elements here, and I want to now test to match, or in this case, instead of to match, is say I want you to check if this object contains that, right? Which is expect object container. So I expect that the value of this, okay, interesting, I expect that this results to be equal or to equal, because I want to check is only the value, okay, I want to check is only the value. Since it received now an expectation, I want you to expect that the object that this have an object that must contain is the prefix of default status. In this case is the status, status. Okay, so what I'm doing here, the intention here to say, hey, I want you to this collections of elements, where here I'm just only creating one element, to be equal to check the object containing. Okay, so I want you to now check the object. Let me actually see if I didn't lose my mind. Object containing. Okay, which is great. Okay, because here we're returning is now this object. Exactly, and inside of this, okay, to equal, okay. So this of course won't pass, all right, because what happened is that we are checking is the object here that must contain is a status. But in this case, this is an array. What happened here is that this is an array. You know? Wait, what? Looks like the object containing status as false with the array. It's actually checking inside of this. So what it's doing is here is to say, hey, I expect that this object, okay, I expect that this object, which must be an array here, so when used with equality check, this when used with equality check, this asymmetric matcher will return true if the value has similar shape. If the value have similar shape, because after all, this is returning is now okay, because after all, this now is returning is an object whose shape is the prefix, okay, and is here when I say I just want to check if this expect value, which is expected object contain, all right, the default status. Well, in this case, not prefix, it's in fact is the status. So I am expecting that this contain is a value of this. I'm not sure I'm doing this right. Because it's this one. So what I can do is something like this, default state. But again, it say yes to equal, okay? But it say to deeply equal. It means that behind the scene is actually checking out the list of property and values and doing that. So if you're not wants to do that, which is in my case, I don't actually want to do that, okay? So to match object here, okay, and now it say, hey, I want to match is the object that contains. The whole point of this, okay, is how you can now actually make sure, instead of doing this, is like, again, now is ask Perplexity for a test here. Wait, what? To match object with the name and the status. With the name and the status. Because all I want to solve this is to say, hey, resolve that. So at that time when you create that object, I want to check if the package, okay, to be equal, right, to equal of the default status, right? And that of course will pass that. So this is one simple way to actually how you can solve this. Next one, support removing an item, which is a state, like so. So it's now going to remove that from our list here. One way to actually do this is by saying, since we are now is the state, and we're gonna remove that element, we want to make sure that that element doesn't exist. How can we say that? So after we define is the setup logic here, and then the testing and the expectations. So I want you to expect that the result array object, okay, does not match. To match object does not contain is the state, right? Pretty simple. So let's now remove that from that. So far so good. That was in fact quite easy to do that, by the way. And the other is supports toggling an item. What does it mean, toggling an item? Yeah, what does it mean, toggling an item? I mean, it's to change the status, if it is. I think it is. Toggling is to support is to change the item, to change the status. Exactly. So what I wanted to check now is to say, hey, I want to expect the result on this object, okay? And because now we are passing now an array, I want you to now to match these objects used to check that a geometry object match a subset of property of an object. You say that must contain is okay, state, okay, and you can say new state here, right? But you're gonna say this new elements that I'm creating here is this one, so it's not true, right? I want you to match with the new state here. So you can see is your test can be some simple like this. It can be as simple as you like. You know, it can be as simple. Let me actually remove the to do here. It can be as simple as you like, as a way to make your life much more easy. So support toggling an item from false to true, new states. You know, and you also are applying all of the other things behind the scenes. Mark all as unpack. All right. Support updating an item. You know, but we are actually value this. But as you can see, some particular pattern started to emerge, depending of the type of test you're going to run that. All right. So you can define is the state, okay, followed by the new state, const is a new state. So what I'm doing is to define is a quality state. Instead of us having to repeat that, one of the great things of this, all right, instead of us having to repeat that, because after all we are creating is this new object, one thing we can do is to say state, okay, I want you to now create this new state object here, spread that, okay, with this object, but I'm going to not only change is the package, is the packet property to true. So instead of us having to manually create that, it of course will work here, because we're saying is that no, I mean is, sorry, my bad. We need to do is this, so access to that object, and they now create the state, okay. So this is another way of how you can reuse some of those reference here by using the spread operator. That's what you are actually doing that. So instead of actually creating is this new particular state here, I just wanted to assign this new state, okay, by saying, hey, this will be is the state, all right. But because I want to create now a new object array that contains the state, all right, but I want to modify the object that is inside of that or one particular property, what I have to do is to say, well, get me that object at that position, and then it's going to pass now the property that we want to update. In this case, the name with this state, right? So in fact, we can do something like this. All right, we can say is this one. You say state, a new state. Okay, state, result. Data, where you say, hey, the ID, which will be 1, only passing the relevant data to this object, as well as the name, okay, and then you say, hey, you know what? This is the data that we're gonna pass here, or the update, state, update, and new state. Update, update data, updated data. Okay, and we're going to define is now this new state. Okay, where we say, hey, this new state that we are creating, okay, it also have the updated data, right? Pretty much that. That's pretty much what we're doing. It's like, hey, give me this object, spread all of these properties, okay, and if you find some property that actually match to that, update the reference, update the values. So once we're able to do this, now by defining is the set of function here, we can say, hey, I want you to now define is the testing and the assertion. Hey, I want you to expect that the new state, or the result, to match the object that we are getting from the new state, right? So because it's something to do, this is what we're gonna do, and there you got it. It actually worked as expected. So here there is a couple of things that we actually put at practice here. One is readability. Second is the ability to work with previous objects as a way to construct our own. And second is working with the previous and the new state as a way to make that happen. So this unit testing is actually quite simple, quite smart. It's not that fancy at all. Okay. Support marking all items as unpack, like so. So what we can do is to say, hey, because I would like to now going through all of these elements and change its property. Okay. So let me now is get rid of this. Okay. And since we have now all of this object here, so what I can do is to say, hey, the new state, it'll be that particular state that whose values, which is under the filter, or in this case not the filter, is the map, because I want to travel to each one of those elements here. I want to travel to each one of those elements here, and then do some operations. So the operation I want to do is the ID, which is the first thing is the data, followed by the index. But in this case, I don't want to work with the index. It's just with the data itself. So hey, please, JavaScript for any one of those elements, provide me is or return. Okay, give me this new. Let me actually do this like so. Give me now is the data, but their pack values, the pack property will set to false, because we are marking all of this as unpack. So what we do here is that after we define is this state, the new state, and the result by testing is this reducer function. So we can say here expect to be, or is, I want you to check if this object from the results, once we apply this operation, is now in this new state, which is to match object with this new state, for that. So after we remove the to do here, blah blah blah, it actually passed as expected. So this kind of test actually becomes quite much more easy to work with, and very very interesting too. Yeah, very very interesting, very 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 interesting by the way. Very 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 interesting by the way. Exercise practice. Solution. Mm-hmm. Mm-hmm. To equal the expected object containing the name. Object containing the expected string matching item. I think if I put my test like this, it'll be quite more clear than do this. Of course, I'm using is but what I'm doing is just defining is an strategy for that. But what I'm doing is just defining is an strategy for that. There are some benefits. So by defining is this particularly padding of this previous state and the new state, a lot of the time you can actually solve some of this. So you have now a way of doing this.
There's two things I kind of want to point out. One, we are testing a Redux reducer. It's a real Redux reducer. It's like coming from one of those Redux Toolkit slices, right? So one of the things that I feel in my like hills that I'm willing to die on is like taking as much of our state management out of our view layer as possible makes it easy to unit test, right? Like whether or not you use Redux or use reducer in just regular React function or use that pattern, right, somewhere else as well. Like all a reducer is a function that takes the current state of the world and a thing that happens and spits out a new state of the world. And because it's a JavaScript function, super easy to unit test, right? Like without having to like mount the component, hit the button. Like you might want to make sure that like buttons are disabled and stuff renders appropriately. But what's really nice about it, it's just a JavaScript function. And we can grab it and we can test it because again, it's just a function, takes 2 arguments, spits out 1 argument. So we can go ahead and we can see that for ourselves. And then we can go ahead and look at some of the asymmetrical matchers to show like, hey, if somebody adds another field to this object because for reasons, right, disabled, enabled, I don't know, what have you, my test won't break because they're expecting a very specific structure. My test will look at the things that I care about and not look at the things I don't care about. And again, like, can you do this with individual expectations as well? Sure, but a lot of the times what you're aiming for here is not necessarily writing less code, it's like getting a better error message when it breaks. Like, cool, you just saw one thing broke, right? Versus like across a bunch of tests versus like, cool, this is one object, hey, it got all these things except for this one thing here. You'll get an error message that shows you the difference in the object. So my first test is in fact already running. Let's just do npm test. I'm going to say item slice, and I'm going to say dot test because I have one called dot solution that's got the answers in it. And so normally I wouldn't have to put the dot test, but because they're similarly named. So 1 passing, 7 to do. All right, let's go ahead and let's make it, it's an empty array. Who's checking that for me? TypeScript is, right? So if I said something like model 14, you can see that I already get a red squiggly line without having like a giant set of tests that I used to have to write. I don't have to write anymore, and I'm happier for it because, again, I like to ship product features confidently. I don't actually like writing tests, right? I just like not feeling really scared whenever we do a deploy, right? Unless it's a change to auth, because I break auth every single time I touch it. Cool. So we have this, so we can expect the reducer. Oh, we have got the result in this case. We expect the result, which is that return value, right? And in this case, we can say that it should equal an array, because we know it spits out an array. And honestly, whatever else gets added to this type, like maybe there's more features other than just name and packed in an ID, like I don't really care, as long as like we get an object, so I can say it should be an array, and we expect an object containing, in this case, name.
It's like the expect the object containing.
Now we
containing
guess just by looking at the type that there is an ID on there, and there is a packed value. I say we can all look at the type, but I also wrote the code, so I happen to know that. And that like an item is an array, we can go second. They've got an ID, they've got a packed, so on and so forth. But as long as like we had an array of one thing, if I put a second one in here, for instance, that will fail because we said an array of one thing, as long as that one thing has a name iPhone. Right? Other things can change in there, but we are validating that there is exactly one thing in that array. That is safer than popping the first thing off the array, right? Because it could have been a second thing in there. You didn't test for that. That means that test didn't fail, which means your code didn't work and your test passed. Worst case scenario. Here, we are assuming when we say that it is an array and that it has exactly one item in it, and as long as that item has a name iPhone, I don't care anything else about it. And I can be cavalier about this because I have TypeScript. Then I can assume that this test is probably more resilient than me trying to get clever with things. So again, trying to index 0 off of it. Because next thing you have to go like, okay, expect like results.length to be 1. Then expect that the first item has a name property. Then expect, you know what I mean? In this case, I can kind of like say that a lot more succinctly. And then if we scroll up here, right, I kind of get a better, like we had that one object containing the name iPhone. Great. And then there was a second object in here. That is a lot clearer for me to read than which one of those, which one of those assertions broke. Maybe the length one would be helpful, but again, for me, this is super clear to be like, hey, there was what I was looking for, and then there was another one, plus above it in red that shouldn't have been there. Cool. And then we want to make sure that it prefixes those UUIDs with item in this case. So we'll go ahead and we will. It fails because there's no assertions. Cool. So in this case, like we could, if I'm going to use a regex. Cool. Now it passes. Like again, I'm just verifying the parts that I care about, and I can move on with my life, and this test will be resilient. Mark.
If most state mutations occur on the server and are refetched to update the DOM, does it still make sense to make all of the unit tests async, or is there a better way to test async code faster?
So if most of the state management is happening on the server, ideally, a lot of this is happening on the server. In this case, like this will also come up when we get to like mocking and spying, which is insofar that we talk to servers. The majority of the asynchronous things we do are talking to servers. Like it all depends. Like if there are things like a transition that should take a certain amount of time, or like something along those lines, like then sure. But yeah, if it's a network request and it's code that you don't control, then like you might not have a lot of asynchronous stuff happening in your code, right? Like this reducer is completely synchronous, for instance. Like we don't usually, for the most part, tend to purposely add promises to our code when we don't need to. However, there are certain browser-based APIs that return a promise by default and stuff along those lines. So in those cases, then we do need to use async code. But like as much as you need, as little as you can get away with, is I think a decent heuristic for that. Yeah. And like these aren't necessarily asynchronous, these are just basically partial matching an object for the parts that we care about so that our tests don't break because something we don't care about changed. This one will be roughly the same concept that we saw before as a pack status of false. I was just gonna show you that you don't necessarily have to do this. If you hate this and you're like, this is not for me, let's look at what it would look like in the other direction. You can see more of the same in the solution. So I could say like, expect, we can grab like the first, we can do like expect result.length. Because we want to make sure like this is valid. To be 1, okay? But whenever you write two assertions, you gotta make sure you write the second one because this test isn't doing what it says on the tin just yet. So then I can expect, so then we
defaults new items to a package status of false.
Could grab item equals result packed to be false. Now the reason that I hate this is because if I mess this up in any way, shape, or form, right? Or maybe it starts out with a default set of things all of a sudden, right? Like this is problematic. Like if let's say that code broke and it's not actually setting it to false anymore, this test would still pass. Versus like when I'm just saying like it should be one thing, it should have an object, I don't care about anything else as long as it's everything I want. This is one expectation, one error message, very clear. This can get a little squirrely. For instance, if I make this true, this will probably be pretty clear because it's pretty easy, but you can see in a bigger object, it might not be. Supports moving an item, right? In this case, we might want to
Okay,
verify
so one
that
assertion per
does not
test.
contain that, right? Like I could verify in this case that it's an empty array again. Like that would technically do the trick, but like spiritually, not really. So in this case, I could say expect result not. I could use a to contain, or I could actually to equal the empty array. In this case, I want to make sure that it does not have image object.
So if that element is not contained in that,
Let's say,
it is supposed to work?
I'm doing this live at this point, but let's see. Real-time follow-up. Yeah, so this guy's like, hey, as long as it's not any object that contains the ID of one, I don't care about the rest of the
Exactly,
details,
it's actually
right? Like, it should not have the one
checking
that I just
okay.
explicitly removed. This way, like, if this became a lot bigger and we didn't want to have this in this test, to the question I was getting earlier, and we wanted to have like one, like maybe larger object that we're kind of pulling in, and maybe I don't want to see it in the test, I can be very like, listen, I just removed this one. I don't really care what's in there as long as it's not the thing I just removed, right? That is effectively spiritually what our code is doing, not anything we might write to get to the same result. Cool. And like we can see like more of the same basic ideas here. Like you can definitely check it out in the solution. In the sake of time, I'm gonna like, kind of like put a pin in it there as well. But you kind of get the point of like how we can be somewhat flexible. And again, this goes to that architectural question of how do we have a test suite that doesn't break, right? So that we trust it, right? Because even if it's like you, as a human, you get to the point where like build breaks, you get to one of those things which is like you don't necessarily believe it was you anymore, which has already made your test suite worthless, right? And so sometimes the way that we structure, the way we think about these things, it's not about necessarily a number. It's about that gut feeling of if you find yourself not believing that the build process failed for a real reason. It's like that is the like sibling of I don't feel comfortable changing this code, right? And both of those are like we're looking like this is a very like technical course where we're like relying on our gut feels as our barometer of success, right? Can I bump that dependency? Can I just run npm like check updates dash u like all like wild and just be confident that if my test pass I'm good? If the answer to that question is no, then like that's where some of these strategies begin to like take place. And some of those will be unit tests. Some of those will be like, listen, like I had a browser go work through the entire application, you know, touch everything like, yeah, we mocked out the network requests or something like that, but like works, I feel comfortable, right? Great, right? But generally speaking, it's usually a cocktail of both unit tests as well as these larger tests to make sure that like some little thing isn't breaking and the big thing isn't breaking, and that's what gets me to that confidence level in this case. There is going to be a little bit of a choice time here, but like if you don't want to make a choice, this is if you find yourself not believing that the build process failed for a real reason. It's like that is the like sibling of I don't feel comfortable changing this code, right? And both of those are like we're looking like this is a very like technical course where we're like relying on our gut feels as our barometer of success, right? Can I bump that dependency? Can I just run npm like check updates dash u like all like wild and just be confident that if my test pass I'm good? If the answer to that question is no, then like that's where some of these strategies begin to like take place. And some of those will be unit tests. Some of those will be like, listen, like I had a browser go work through the entire application, you know, touch everything like, yeah, we mocked out the network requests or something like that, but like works, I feel comfortable, right? Great, right? But generally speaking, it's usually a cocktail of both unit tests as well as these larger tests to make sure that like some little thing isn't breaking and the big thing isn't breaking, and that's what gets me to that confidence level in this case.
So, well, that'll be all for this video. Take care. Bye-bye.